Welcome back to Physics But Awesome, and also to the third and final part in the mini-series about pseudoscience. Last time in part 2 we came up with some theoretical criteria for distinguishing between science and pseudoscience, and this time we're taking a look at a more practical example of how pseudoscience operates. So, let's go! Pseudoscience illustrated by example. All of this works best when I just make up an example. Have you heard about green jumpyism? Let's say that somebody observes a frog jumping and deduces from that that green animals can jump real good. And then you can go on and turn it into a whole theory with saying, you know, those with more bluish green can jump up really high, and those with more brownish green can jump really far, because brown is the color of the earth and blue is the color of the sky, and all that, you get the gist. When pressed and when confronted, a green jumpyist can say a couple of things. First, they can point out that science has been wrong in the past, and also that science freely admits it can never know everything. Second, they can point to examples that support their theory, like grasshoppers or geckos. And third, you can probably also come up with some statistical evidence for green jumpyism. The thing is, if you look at this, it appears to be really solid arguments. And that's exactly how pseudoscience works, by appearing legit at first glance. So let's give it a more thorough look, shall we?
What's your name?
Chris?
Have you ever been wrong with anything in your life ever?
Anything? Of course.
So why then should I trust that you know your name?
It's a classical strategy to undermine something by casting doubt on it. And with a system like science that makes it a point to constantly doubt itself, it's even easier. Because that's a really important facet of science, that it can never be final, it can never be certain, it can never be all-encompassing. Therefore, you can absolutely make the point that science doesn't know everything. But the thing is, that's not a deep insight. It's trivial, it's built into science. Also, even if your argument is that something else is wrong, this does not mean that what you're saying is right. It's actually just an incredibly cheap trick, but surprisingly many people fall for it. An alternative explanation is only then preferable if you can actually show it is better in some way.
Have you finished reading the book yet?
No, I still haven't read the last 2 chapters.
How do you feel about the main character dying on page 10?
No, nobody dies on page 10. I've read page 10. Besides, there isn't even a main character, it's the Feynman lectures.
But you admitted you haven't finished the book. Clearly you cannot speak on what happens in it then, can you?
What? Again, you can make the argument that science probably doesn't know everything there is to know about jumping and the color green. But we found out some things already. We can test things already. And we can certainly rule out that the color green and jumping have this deep connection that is implied by green jumpyism. And that's a really meaningful difference. Man, I really hope it's not gonna rain later when I go running. You just have to praise the rainmaker when leaving the house. And it will not rain. The what? The rainmaker. He makes rain. He is very busy though, so it doesn't always work, but it worked perfectly yesterday. Examples that fit a theory is a very slippery slope. That's because if you really search long and hard enough, you will find examples for essentially anything. The question is, how often does this really happen, and how much contradicting evidence do you have to ignore? So there's something called spurious correlation. It means that There are things that are completely unrelated, and obviously so, but they just by chance behave in the same way over time. So they have the same time evolution. Some of them are quite hilarious. I picked out a few of them here. And the thing is, again, if you really want to find something, you always will. There are just so many curves that are completely unrelated, but just look the same. Statistical evidence is in general a very tricky thing. You know, you can say correlation does not imply causation 100 times, but our brain will still jump to a very different conclusion. Because our brain is a pattern recognition system. Implying causation is all it does all day long. And that's why accepting randomness is such a hard thing for us to do. We always need a reason for why things happen the way they do. We always prefer a narrative to just chance. And that's why statistics and probability are areas where you have to be very careful, because it's so counterintuitive to the way our brain works that you're very easily fooled or misled. Also, did you spot something is missing? Falsifiability. The people involved in pseudoscience never doubt their own ideas. Quite the opposite, in fact. All the rigorous doubting they apply to science is instantly forgotten once it's about their theories. So, of course, green jumpyism does not exist in... with it being the internet, it probably does now. Anyway, this example is just there to show how actual pseudoscience operates, and we can show scientifically that the way it is supposed to work, according to its founder or followers, is complete bogus and does nothing. And any effects you might get are due to statistics or psychology or other factors like that. Why is it so widespread then? Why it is such a thing? I've already mentioned narrative, and that's the crucial word here. All pseudoscience is connected to a deeply held belief, or even an ideology, or even a complete conspiracy theory. It is not a method of learning or knowing. It is a strategy for defending what you want to be true. An aggressive form of wishful thinking, if you want. And that's also why the followers of pseudoscience can almost never be reached with arguments or data. Cargo cults again. And with that, we finally go back to the cargo cults from the introduction from the very first video. The story of cargo cults is not so much a story about one specific island or culture. It really is a story about the human mind and human nature. And I picked it because it helps us understand two key features of pseudoscience: the cause and the effect. As for the cause, to our monkey brain, there is no difference between science and technology and magic. And this is very apparent in the cargo cult example. But we should not fool ourselves. If you go to any Western culture, there is also essentially zero people who understand how aircraft work or how radio works or radar. Most science really is way beyond our intuitions and therefore literally incredible. Anything found in science since the 1800s is way beyond us, and anything found since the 1900s is outrageous. Consequently, many people struggle to accept these findings. They don't feel right. And secondly, we also see the effect of pseudoscience. Nothing happens. Because the cargo cult version of machines aren't machines. They were just built to outwardly look like machines. And that is why pseudoscience is so attractive to us humans, to the human mind. And that's why some version of it will always be there, sadly.